Perfect. I think now we got all the students that typically here. So, like I said in the previous lecture, we covered a few slides here. We continue with the slides, and then we'll get going with the questions afterwards. Okay. We covered on this operational and the data warehouse. I would like to make sure we have a good clarity on OLTP systems and OLAP systems. That's a very important point for me. And then also, by end of last lecture, I also would like you to understand that, we have a clarity on the Kimball approach and Inman approach. And we touched on these two topics slightly, but I think the key point for me is Kimball approach is more dimensional modeling. Dimensional modeling in the sense he clearly talks about creating dimensions, creating a fact table, how they link together. We have a different concept that we're going to spend completely 1 or 2 lectures on that. So we're going to spend time on this Kimball approach. So it's purely a dimensional modeling. And then Inman approach is we call as kind of a enterprise-wide data warehouse solution. He starts the design in a typical third normal form. Again, I'm introducing some of this terminology that you would have done if you have taken a database course. Normal forms are the ones that we try to normalize the data as much as possible so that we don't have duplicates. Okay, there are different types of duplicates we could introduce into the data warehouse and into the database. And in case of a transactional processing system, we would like to avoid the duplicates as much as possible. Okay, so when I say the reason why we do the eliminate the duplicates in case of transactional processing, because we want to give faster response to the users. When I try to give a faster response to the users, if I have if I'm trying to update the data in the database, if I have 10 duplicate records, I need to update all the duplicate records for a transaction. So if I have unique records, so I will go and update that one record, a transaction is done, the user get the response right away. So that is the importance that we give for a transactional processing system. That means we are eliminating the redundant data from the database. So those are the things called normalized forms. You can search Google, or if you have a database book, search for first normal form, second normal form, third normal form, and try to understand what they are. I'm also going to post a topic related to that. Very good example, easy to understand slides that I'm going to post online, so you should be able to see that in the next lecture. But again, the normalization is critical for a transactional processing system because we don't want to have duplicate records. Coming to the data warehouse, that restriction is gone because we're not updating anything, because we don't update anything on the fly in the data warehouse, as we have already discussed in the last lecture. Again, Inman approach, what he says is, and typically in a transactional processing system is a normalized, most of the transactional processing systems are a third normal form. And Inman approach says that we bring in third normal form as is into the data warehouse and then build the star schema on top of it. Again, wait on the star schema. We will come back to that point in detail in the next coming lectures. But the point for me is the Kimball approach, he starts right away with the star schema design. Whereas Inman approach, he starts with the three-dimensional third normal form database design and then expanding to a star schema. So again, when we say this Inman approach here, so what's going to happen is, so he is going to talk about more enterprise-wide data warehouse, because he's bringing everything into the data warehouse, whether you're focusing on a specific business area or not. Whereas the Kimball approach, he starts with a focused approach, focused model. That means I'm going to build a data warehouse for a specific business area. So when I say specific business area, it could be a client processing department, it could be sales department, it could be a marketing department. So you are focused on a specific business process and build the data warehouse around that. Okay. So in the next couple of slides, we're going to introduce new terminology. So just bear with me. So we'll go from there. Okay. So before I go, okay, that's good. We're going pretty good here. Okay, so again, in this Hinman approach and also Kimball approach, some of these definitions will apply for both of them. Again, it's a data warehouse is a subject oriented. That means that's another point we would like to highlight. So even though Hinman approach starts with enterprise-wide database, then he is going to focus on a specific subject area. Again, he's going to extract the data for a specific business process. As you can see in this example here, this is a very good example for automotive industry or kind of insurance industry here. So insurance could be different type of insurances you could have. You will have auto insurance, life insurance, health insurance, casualty insurance. These are the different insurance types an insurance company could offer. So as you can see here, one business model have multiple business processes, like we all know. Okay, so you could build a data warehouse for automotive section, and you could build a data warehouse for life insurance, so things like that. And then here in this case, once we have all that information, then we could go back and look at it. What are the different type of dimensions? What are the different type of dimensions that we would like to have in the data warehouse so that we can do the analysis? So typically, the customer is the most common one. In this case of example here, you have policies, and then you have premiums, which is again a measurement. The claim is also a measurement. So you can see here, the region, what kind of region you have, how many claims you have in this region compared to this region. That could be another dimension. Time is a standard. We always would like to know time dimension because we would like to play a lot with the time, because I would like to know what I did yesterday, what I did last year, same time, last quarter compared to this quarter, 2 years ago what we did. So that kind of analysis is very standard. So time is a typical dimension that we will have in every data warehouse. Okay, the point that I would like to highlight here in this case, subject oriented in the sense, so you're mainly focused, even though you have a big enterprise working global organization doing a lot of businesses. For example, if you take my own organization that I work for Case New Holland, a New Holland company. We make tractors, we make construction equipment and all that. So not only that, we also make truck business. We do a lot of other businesses in Europe and other areas in the world. So if I have something like that, and then if I build a data warehouse, I should focus on a business process. Let us say I have an agricultural business, construction business, trucking business. So if I mix things, it might be helpful for enterprise-wise people that are very high level, like a VP and above, that are overlooking all the businesses. But if I go down, people that are working in the organization more focused on their business process. If I have a sales and marketing team for agricultural business, and they don't like to see and compare the data with the trucking business. If I have a sales and marketing team working for a construction business, they don't care about what goes in the trucking business compared to agricultural business, because as you know very well, construction business completely works in a different model, because in other words, different dimensions, different characteristics, different inputs. So construction is booming in one region versus other region, and agricultural is booming in one region versus other region. The last 3 years, we had a very strong agricultural business in North America, but next year we are projecting low agricultural business in North America. But I think we are expecting for better demand in India, China, and those kind of regions. So the business model works on different dimensions, different characteristics. So that is why when we build a data warehouse, we need to focus building a data warehouse on a business process. So we can, we could have an enterprise-wide data warehouse, but we also need to focus on business process-wide, so that it's easy for the people to understand in those specific business areas. It's easy for them to analyze the data. Okay, so as I was telling, Hinman approach, we take a third normal form as it is from operational system, and again, I'm expecting majority of the operational systems or transactional systems are third normal form. Again, it's not a rule that they have to be in third normal form, but majority of them are in third normal form. So that's why I said, typically we take as it is into the data warehouse in the third normal form, and then expand, either design a building, a fact table, dimensional table, and star schema and things like that. Okay, so coming back to subject-oriented data collections, I want you to focus clearly. You might have different operational systems working in your organization, supporting different transactions. Don't expect that you're going to convert every one of them or bring every one of them into your data warehouse. You need to clearly analyze, clearly decide what data you need to bring into the data warehouse that is going to help the business make the decisions, strategic decisions, operational decisions, managerial decisions. Okay, again, what kind of decisions am I going to make? If it's a marketing program, if it is a marketing management, a marketing team. So marketing team always would like to come up with the new marketing promotions. So how are they going to come up with new marketing promotions? They would like to see, okay, we introduced a promotion last fall, in this region, it really did a great job. Can we try to explore applying a similar model, similar promotion in another region and see if it works this year? Because it worked really good last year. Or we could say, last year, the marketing team introduced this program, and 30% of dealers or 30% of the business units did an excellent job, and 70% didn't even get the message that this program is so good. So now this year, the marketing team might decide, okay, I would like to introduce the same program, but in a different way. Like, okay, take the example of last year's data and say, hey, look, they go target the 70% dealers that they have not participated in the promotion last year. And then this year you can say, take the data that from the last year, the 30% dealers that they did exceptionally well, the profits they made with the promotion, the money they made with the promotion. So now you can take that information and then show to the remaining 70% and go back to them and saying, look, we have introduced a similar promotion like what we had last year, the same time in the fall or a spring or summer, whatever seasonality that you have based on the business. Again, I'm speaking in my own way because I've been in this industry for the last 15 years. So these are the things that we normally do because we like to analyze in different ways, different dimensions. Okay, not only just promotions, we look at other things, pricing conditions. Okay, we increased the price last year. If I do the same thing this year, what is going to be the impact? So data warehouse has the data, so we can go analyze and then make the right decisions. So like I said, take the data from last year and print the reports and say, look, these dealers took advantage and made this much money, and we have the same promotion this year. Why don't you try it out this year? So it gives an impulse for the remaining 70% of the customer or the business units that you're dealing with. So they might get interest in seeing the previous year's data. They might get in. Okay, so again, I see some of you are telling me that you don't have a audio is not coming out correctly. So again, I would say probably on your local end because I have 100 students, 100 plus students here. So looks like everything is good. Whoever is having problem, just I don't see the name here. Probably you might have to wait because sometimes it just takes some time to get everything is hooked up and installed correctly. If it still continues, you might have to go out, come back in. So I think that is the best way. Okay, good. So I think hope it is clear for you because I don't want people to think the data warehouse means it's a big database. It has everything in it. It's a huge in everything that belongs to the company is in one place. I don't want to keep that kind of thoughts on the data warehouse. For sure, data warehouse is big. I don't claim that is wrong. It is for sure big because even though we take one business process or 2-3 different business processes into a data warehouse, that itself makes very huge because we are going to store a lot of data for historical analysis and for auditing purposes and all that. So we are going to keep a lot of data. So it is going to grow significantly pretty soon within no time. Again, the size of data warehouses that I worked in the past. So we had a data warehouse. We started with around 700 megabytes, and then it reached 1 1 terabyte. I think it went to up to 1 terabyte, and then 700 gig. I'm sorry, not 700 meg, so 700 gigabytes, and then it went to 1 terabyte, and then after that we put the controls. In other words, we based on the business requirement, based on the business needs, we put archiving process in place so that the data warehouse doesn't keep growing big. So it's always sustained the growth. We call as so it is growing in one side, and again at the end of the year we're going to delete some data. So we are maintaining 1 terabyte to 1.5 terabytes in between that range for this one data warehouse that we have today in our organization. And we have another data warehouse where we have almost 10 terabytes of data. It is still working great, performance is great. And then we have another data warehouse, I think it is around 30 terabytes. But anyway, so that is a maximum I have seen, but some of you might have worked with bigger companies like Google and other people there. It's a very big data warehouse, as you might have seen. But again, I'm just speaking of my experience, but even 10 to 30 terabytes is not a smaller amount. It is going to add significant effort in managing the data warehouse because you'll have a lot of performance issues, a lot of other data integrity issues and things like that as the data is growing. So we find new problems every time when we add new data into the data warehouse. So it's always challenging. So we'll continue here, and then we'll take up the questions. We'll take from after the first break or something like that, and then we'll take up the questions. Again, the next point is integrated data collections. As you can see here, so you could have multiple data sources. Again, the reason why I said data warehouse is there for analyzing the data, and you could have multiple applications doing the same transactions. Again, very simple example for me is we have order processing system in North America. We have a different order processing system in Europe, and we have another flavor of it in APAC regions. So again, we're trying to normalize this after we merge, and we started with one company, and we combined with another. We kind of merged with another company, and then we have expanded to a global, very large organization. So we actually, so with that, each organization when we acquired, we also acquired some of the applications that came along with that, and we're still trying to integrate and trying to make one global order processing system, which is unique for the entire organization, but we're not there yet. And that's very common in the industry, the way that the organizations are growing, acquiring one business, other business, and they try to consolidate all the applications, but it is not that easy, so it will take some time. So you will have different applications for the same process. So order processing or claim processing, whatever process that you have, you could have different applications because of this nature. So you can have application A, application B, application C, application D, doing the same kind of business model, and you're trying to bring into the data warehouse, and each one of them has different type of way that manage the data. So if I want to represent male, female here, application A is doing M and F as their characteristics, and application B is doing 1 and 0, application C is doing X and Y, and application D is doing explicitly male and female. Again, each operation, each application is doing having their own way of handling this particular data, but at the end of the day, we want to handle that as male and female. Same thing here. So you have different applications, having different measurements. Like if I come in North America, we'd like to do in yards, and then if I come in India, we would like to measure in centimeters, and also in like an application in North America, we might like to measure in inches. Okay, so same thing. There are different descriptions in different applications and different types for the same type of data that is coming into the data warehouse. So the goal for us in the data warehouse is, as we are getting these multiple systems, multiple systems representing the same type of data in different ways, when it comes to data warehouse, we would like to somehow transform this into one mode of representation. I don't want to represent some with male and female, some with 0 and 1, some with X and Y, and as the data comes in, put it into the data warehouse. Then it's going to be a nightmare for me to do the analysis. Okay, so this is the transformation that we talked about. So we are going to address that very well. And again, conflicting keys. We're going to talk about all those things because again, ETL is a big chapter that we are going to touch as we go into the next few sessions here. So we're going to talk about this transformation extensively. So the point for me is very important: integrated data collection. So you could have multiple data sources coming from different regions, different languages, whatever it is. And when come to the data warehouse, you need to consolidate. You need to transform into one meaningful representation, so that when somebody is running a report, they're always confident that data is coming in one format. So in other words, what's going to happen is, so when we are representing this in centimeters, inches, yards, and whatever other meters, whatever you have here. So when we put it here into the data warehouse, we are going to put in one measurement. Okay, so you're going to put in one. So as you can see, then people will ask, why are you putting in one, and then how are they going to translate? So whatever translation that you have used, so we're going to use it back. If, for example, if I'm running a report in India, and people in India would like to see the data in centimeters. So if the data is in centimeter in data warehouse, it's easy to transform. But let us say I have same report is run by people in North America. They would like to see the data in inches. They don't. It's confusing them if I show the data in centimeters because they are not used to it. So what I need to do is, when a person running a report in North America, based on the region that they're coming into the data warehouse, they will see the data automatically transformed or translated into the inches or yards, and then it will shown in the report. So it is that is a key point for me, because we would like to have one standardized mode of representing the data in the data warehouse, and then whenever a local user is trying to run the report, we will present in a local format, in a local user needs, is going to be satisfied for him or her. But for an organization wide, we're going to represent in a one particular uniform notation or uniform measurement, so that it is going to be easy for the people to understand. So I think unit of measure is one example, but I think many of us face issues with the currency exchange rates. And again, all these are the decisions that you're going to make as part of data warehouse design. So that is why I was telling, data warehouse design is not a simple process. We have to sit and talk to the business. If it's a global organization, you need to start talking with the business units in different regions, and then start working on these small things to be sorted out before you go to the next step. Because ETL is the biggest part of your data warehouse design, because if you have a poor ETL design, then you will have a lot of issues, a lot of questions you need to answer throughout the life of the data warehouse. So you need to be very clear and concrete on this. And most of the time, the currency that you would like to represent in the data warehouse is based on where your annual reports are going to be presented. Let us say I have an organization, global organization, but my headquarters is in India. So if my headquarters is in India, my company is traded in one of the Indian stock exchanges. So if it is traded in Indian stock exchanges, I would rather represent the data in rupees in my data warehouse. So that, because most of the people doing the analysis in the data warehouse would like to see the data in rupees, even though I have business coming from North America, Latin America, Europe, Russia, Latin America, everywhere. So when I'm dealing with the business in US, you will be getting the data, you'll getting the currency in dollars. The transactions will be done in dollars. If you're doing with the UK, you'll be getting the data in pounds. But the point is, if the company is traded in India and you would like to represent the data in rupees, so you transform the data, you translate the data into rupees from operational system, because operational system might be storing the data in the local currency. Because if I have an operational system working in UK, it is processing orders in UK, so it is going to store the data in pounds. If I have an operational system working in US, and it is going to store the data in US dollars, because It has to deal with the taxes, it has to deal with all of those things, and if it is doing back and forth currency conversions and all that, it's going to be a nightmare. So it is going to handle that in local currency most part in most of our organizations. So when it comes to data warehouse, we are going to transform that. We work with the business and say what is the best way, and typically, like I said, currency, we tend to choose the currency that is based on the trading where you trade your organizations. If your company is traded in US, you're going to store in US dollars. If it is traded in Canadian market predominantly, then you have Canadian dollars. So it is what it is. For the local operational system. But when it comes to data warehouse, you need to be a little bit higher level and then put the data in that particular format that is going to make sense for entire organization. Because as you can see here, another important point you need to understand, so you have four different applications. So these four applications might be in four different regions of the world, and that means you have four different regions of the people working on different applications here. Coming to data warehouse, you have all these four regions, people might be accessing this data warehouse as one entity. So you don't build a data warehouse for each region. Okay, so I'm not telling you that's not the right approach, but if you have a global organization, I would present the data in one data warehouse for all the regions, because you can do the analysis by region. For example, if this region want to do only for them, you can always pull the data down for their own region and then do analysis whatever they would like to do. It doesn't need to have that particular regional data warehouse for them alone. Okay, and then that means you're having their own infrastructure, their own everything. So you're kind of apples to apples. You're moving apples to apples here. So let us say, for example, in here, I think even in India, you have different kind of mangoes. Okay, so you have, I don't know. There are a lot of names. I can't spell all the names. Probably 10 or 15 kinds of mangoes out there. And you could put all 10 different kind of mangoes, each one of them in different baskets, or you can put everyone in the same basket. And then if you have a way to sort them out, that's all you need. Okay, so that is what I was telling here, because we have different application users are coming into the data warehouse to do the analysis. So don't expect that these people are going to only use operational system application A, application B, application D, application C. So as soon as they know that there is a data warehouse having their data there, they would like to go there and try to do the analysis in that data warehouse, because it has all the data, and it helps the reporting, it helps the analysis powers. So users will come automatically. So that is why I was telling, based on the business need, based on the organization that you're dealing with, so you are going to design the data warehouse to the needs of the organization. So it's very important. So that's why we're going to touch those points as we go into the next lectures. But at least I would like to highlight here, integrated data collections is a very important point, and you need to take a step back and take a look at it. Where do I draw the line? Okay, when I say, there are some people will say, okay, I would like to build a data warehouse by each region. Yeah, probably they're right. I'm not saying they're wrong. There could be a good argument for that. But data warehouses also, if it's a global organization, if you have all the data in one data warehouse, then it's much easier, because you don't have to go to different data warehouses to pull the data together. And we also have, let me see. So we also have a situation. Color here. So you could have an example here again. Very simple thing. This is a North American region, okay, and then you have another region here like Asia, and then you have a Latin America region, okay. So let us say you have three regions, and you have a global organization doing the business. All these are belonging to one company. You are doing a business in all these regions. So for sure, you'll have some people here, top level management. They would like to have a complete visibility of all the regions, because they would like to see what are we doing globally. Okay, even though each region is focused on their own data, but there are some people who would like to see globally. Not only that, sometimes I have seen people in North America would like to see what similar business is doing in Latin America. So what similar business is doing in Asia? There is always people are. It's the same organization. It's the same one global organization. So we would like to take advantage of regional aspects, the behavioral aspects, how the business is doing, performing. So you could bring in some of the promotions the people they're using in Asia, people that are using in Latin America into North America. So it's always a possibility. So I'm also there could be people who are designing data warehouse. They will say, oh, bringing everything together is going to be very huge. It's going to add a lot of complexity. Let's not deal with that. Let's put it in 3 different data warehouses. And I know there are only 10% of the organization would like to see the global organization view. For them, what I'm going to do is I'm going to take a view out of these things and probably build a virtual kind of data warehouse, a virtual kind of view that gives these 10% of the users access to this data, and then I'm completely away from the performance issues and that kind of strategy. So I'm not saying that is the wrong approach, but again, you need to take the balance. What is the right approach, what is the wrong approach, but you need to clearly justify when you make these decisions. Those are the design decisions that we're going to talk as we go into this course, because things look trivial, but it's very important, because I could build a data warehouse with all these regions in one, or I could build 3 different data warehouses. So if I build 3 different data warehouses, I will have 3 different infrastructures, and I will have a production box for this, production box for this, production box for this, and then a test box for this, development box for this, test and development for this, test and development for this. You can see all the complexities here. We are spending a lot of money for each region. But if I have one production, I know it's a very large, but your infrastructure is kind of streamlined. You have one production server for globally, one test server globally, one development server globally, but at the same time you're also adding complexity because you're bringing everything together, making sure North American data is integral to the North America and all those things. Again, there is an argument we can make back and forth, but we need to evaluate the case by case and then make the right choice for the organization. But again, these are the type of things that I would like to discuss in this course, because it's very important, and also for me, that's the basis for this class, because it's very important for me to touch these aspects, because not many textbooks go that level, because they're kind of very little bit high level. So I would like to brainstorm these scenarios, and I'm sure many of you have a global experience. You can bring in those discussions, valuable discussions here, and we can empower this lecture material very well here, okay, for this course. It's almost 30 minutes. Let me stop the video here and then take up these questions, and then we'll go further. Okay. Okay. Let me go back to these questions here quickly. Okay. Let me go back too far here. Start the actual lecture. Oh, okay. Certainly, I have started. I'm sorry, I didn't see your message there. Okay. Recording is not started. Okay, we have started recording. What definition of data warehouse we have to use in the exam? Swapnil, okay, that's a good question. If I ask a question, I don't even think about the question now, but my questions will be pretty straightforward, except in case of open book exam, you have a choice. You can use either one. Because it's more. I even like if you come up with your own definition, combining those 2 aspects. That's perfectly fine. But in a closed book exam, I will be more specific. Define the data warehouse, Kimball approach, whatever it is. Okay, so it will be more specific. Okay. In case of inmet approach, we take third normal form. Yes, input and output form. Yes, it's going to be whatever third normal form that is we have in the source system. We're going to transform everything into the data warehouse, and then we are going to build on it. So it's going to be third normal form first, and then we're going to talk, what is the next design in the next few lectures here. So we are gathering the data from various sources for analyzing it. then how can we differentiate with mining, as it is also doing the analyzing and the data and gives some pattern of the data. Okay, let me put it this way: data mining, and data warehousing. I think looks like some of you have taken data mining course already. Again, you have not given your name here. I have a bits ID there. I can't talk to you clearly, but whoever posted the question here, looks like you have taken the data mining class, or you have some experience in the data mining area. So as you have known very well, data mining, it mainly works with some kind of pattern analysis, some algorithms and things like that. Here in data warehouse, we don't talk about any algorithms. We don't talk about any mathematical formulas or anything like that. We are purely talking about common sense, purely talking about how we are going to transform the data so that business can do the analysis in an easy format, easy way. Okay, we want to make the data in a business um, uh, view very easily so that they don't have to think when they try to run the reports. So as soon as they see the data, they know what they're looking at it, they click it, they get the data that they would like to see in a format they would like to see. So we want to make the life easier for the business users so that they can write the report themselves. They don't have to depend on somebody else. If you look at 20 years ago, if the business wanted a report, they had to come to IT, and IT worked with the business. Okay, what format do you need, and all that. So today, I don't want to deal with that. I give the data, business can go and do whatever they like to the formats. The page indentation for the reporting. I would like to put this data in this report, this page, that page, page breaks, and whatnot. Total breaks, everything they can decide. I don't have to deal with that anymore. So that is the goal of data warehouse. I want to give flexibility for the business users as much as possible so that they don't have to think about or coming to a dependency on another person to develop some reporting, some analysis for them. So how are we going to differentiate? That's what we're going to talk in this course, because we're going to bring everything into one data warehouse, and then we need to design in such a way that so that the business can easily differentiate, because you will have, let us say you have different applications coming here. These different applications data is coming into. So whatever data is coming, probably you have an indicator for which application is coming if it is important for me. If I don't care which application is coming, it's North American application, European application, I don't even record that information. But I would like to know, is it coming from which region? Is it coming from the North American region, APAC region, Asia region? Then I will have some indication. Along with this, there will be indicator in that data that is coming there. Is it coming from North America, whatever it is. So immediately when I'm trying to differentiate, if I'm trying to pull the data for North America, I have an indicator, even though that might not be coming from the interface. The data is not actually coming through the interface. Let us say I have these 4 attributes here. Okay, so let us take, for simplicity sake, I'm taking, there is an attribute male and female. There is some measurement attribute, some descriptions are coming, and then some keys are coming here. Okay, whatever it is. So when the data is coming here, along with that, I'm also going to say, because if I want to differentiate, like you're telling here, I want to differentiate the data. So immediately I will say, if the application is coming, data is coming from this, along with this transformation, I'm also put another new attribute in the data warehouse saying this application is coming from North America, so I'll put NA. And if this application is coming from APAC, I'll put APAC. If this is coming from Europe, I'll put Europe as an indicator. And if this is coming from Latin America, I'll put Latin America. So same thing. Again, if data is coming here, I'll put that. So again, the point I'm trying to make here is, so you will design the data warehouse in such a way that you can do all the analysis that you would like to do. So you already have these requirements. What type of analysis I'm going to do? I'm going to do the analysis by regional. I'm going to do the analysis by time. I'm going to do analysis by customer. I'm going to do the analysis by promotion. You already know that. So based on that, you're going to propagate the data into the data warehouse, and you will make sure you have clearly defined attributes in your data warehouse so that you can differentiate the data. I don't want to have a clumsy data warehouse where you have all the data in one place where you can't use it. So that is the goal of the design that we're going to learn in this class. Okay, we're going to touch on those points elaborately as we go. Okay, hope it is clear. If not, again, post the question down so I will come to that. Does the data warehouse use regression equations for predictions? Again, Mr. Murali, again I'm telling you, we're not going to use regressions, nothing. No formulas that we're going to use. It's pretty much we're going to take the business data into the data warehouse, and then we're going to make that data available for reporting. That is, we're going to elaborate that as we go, but I don't want to expand that further because we're going more towards data mining, which is not my area of expertise. But again, we're not going to have any equations, any mathematical formulas, or anything like that. If at all, any formula that I will use, the transformations. That's it. Okay, that's good. Okay, that's good. We take that question. Okay, we go down. The gathering data various sources. Okay, we answered that question. So looks like Madhav suggested whoever is having problem with audio, they can go to audio, integrated voice conference, volume and increase the volume. Okay, thanks Madhav. So that's a good suggestion. I'm going to post this to everyone so that if they have a problem in the future, they can also, because Madhav posted this to me. Okay, so everyone should see that message now. So it's a good. Okay, thank you, Madhav. Appreciate it. So, what is the kind of hardware we are looking at in case of 10 terabyte data warehouse? Abhitesh, that's a good question. We will touch on that as part of this course, but it is not today. For sure, we're going to touch what does that point. Again, the hardware and the performance, all those things are slotted for the second half of this course. So we're going to touch that extensively. Okay. In conflicting is how is resolve the picture key. Okay, so we're going to touch that one too. Okay, that's fine. Do you cover tools like ETL, Teradata, Informatica, etc.? Yes. It's a long name there, like my name, Chandrasekhar Reddy. But anyway, Padmanabhan. Okay, that's good. Sorry. So for sure, yes, we are going to touch a little bit. I'm not going to go deep in that because I have used Informatica myself, but I've not used Teradata or any other ETL tools. We have built our own ETL process, in-house built ETL process. I'm going to show you some of the scripts that will show how the ETL process is. You can build your own ETL. You don't have to go and spend a lot of money for ETL tools if you're building a simple data warehouse. So we're going to touch on that, but I'm not going to go too much deep into the tools like that because they're more. What I would say is, I would like to know what it is. That's all I need to know because as long as they are ETL tools, if I'm going to buy Informatica, I'm going to buy Teradata, I'm going to buy whatever it is, I'm going to get trained on that and I'm going to use it. But as a data warehouse designer, I need to know there are tools out there like that. So that is how this course is designed. We're not going to deep dive in any of the tools. We're trying to give you the knowledge of the data warehouse, how we can design, some of the examples which we touched before. Those are the key aspects that we're going to touch in this course. We're not going to go in depth on any of the tools. We're going to give different pointers and different information so that you can pick and choose based on your needs because there are too many tools out there and we cannot focus on one tool. It's not going to be justifiable. Okay, but for sure we're going to give some examples for that. Who will decide data collection in data warehouse? For example, like male, female, okay, data warehouse designers or the organization mandates it. Okay, this is again, all these decisions are done with the data warehouse designers because as a data warehouse designer, you know what you're designing. So then you express that to the business, explaining business. Okay, look, so we have these different systems, and now we decide as an organization we would like to put everything in one data warehouse. And if I have all the data in one place, I would like to make this data as uniform as possible so that everybody, when they run the reports, it's easy for them. And then when a local user, end user is running a report, he can still use his own metric, his own way of thinking, his own look and feel of the data that he can see it. But as an organization, we would like to normalize, we would like to represent in one uniform way so that it's easy for us to do the analysis. Okay, so you make that take your discussion as part of your design process with the business, and then make sure everybody understands it, because this is a very important point. Because okay, I said in data warehouse there's a lot of information that we have. All these nitty-gritty details that we talked, these are all called metadata. So these are all data about data, because you have different data elements coming to data warehouse. Now you're making a decision, so now you're going to put this information in the metadata so that in the future, there is some other user comes on board from APAC or North America. They just go to the metadata. They can see that okay, in this data warehouse, all the data is represented in US dollars, or in this data warehouse, all the data is represented in Indian rupees. Or everything, every measurement is in centimeters, or every measurement is in inches. All this data is stored someplace, and we call that as a metadata. We're going to touch that extensively. So whatever decisions you make like this, you're going to capture that and present it someplace so that when new people come, new users come, they can have that information, and then it's easy for them to understand. So that is called metadata, and we're going to touch that extensively as we go. Hope that is clear, Mr. Madhav there. Lowest unit is the natural choice for the data warehouse. Excellent, Venu, you're getting to the point. There is also another point that we're going to go. That's one of the things that as we go into the lecture, is the lowest unit is what the natural choice for the data warehouse. It's not the lowest unit, but I would call the lowest level of detail. Okay, when I say lowest level of detail, that means, let us say I have an order with 10 different line items. So I could store the data at the order level, or I could store the data at the line item level. So what is the lowest level of detail that you would like to see? Okay, so if I would like to see the line item detail, that means I would like to see how many units sold, how many products sold, then it's better for me to store the data in the line item level. If it is order level, that means one order might have 20 lines, one order might have 100 parts, whatever it is. Then I need to go break down. So if I have the lowest level of detail, then it's easy for me to aggregate. Okay, that we'll touch that point in detail as we go. It's one of the design points for us in the data warehouse. Okay, infrastructure. Do we have any better advantages of having region-wide data warehouse? Rajeshwari, I would say again, I want you to think about it. The region-wide data warehouses, again, you need to clearly evaluate what is, the percentage of users that are going to look at the global data in a data warehouse, and what is the commonality. Because let us say, for example, I have a business user in North America. Their thinking is completely different than a business user in India, and a business user in Europe, because these business users are accustomed to the local environment, local business trends, local weather conditions, whatever it is. They know very well about that. So just like we talked just before we started the lecture, the weather in Bangalore is so good, and weather here in sub-zero degree centigrade temperatures here. So I can speak what the situations here very well, because I've been here for the last 20 years. Okay, so I like it, I don't like it, whatever it is, I can speak to that very well. So that's the same point here, because region-wide data warehouse, like I said, you can argue either way, and you need to make the choice based on the needs of the organization. So if you give a little bit more detail, Rajeshwari, put the post in section, or we can elaborate the discussion on that, but I would like to leave it there for now. And then, okay, in data integration, do we group the data by their functionalities from the database so that data can be pulled from the warehouse based on those functionalities and analyzed? Okay, so if I understand your question, Ananya, correctly here, so when we pull the data, by functionality, by business process, we are going to put it into a business in a specific area in the data warehouse. I don't want to mix, for example, if I'm talking with orders, I don't want to mix with orders with the shipments. Okay, there could be, and also same thing, if I have an order information and a claim information coming, I don't want to put claims along with orders, because that is not the way to design a data warehouse. I would like to design a data warehouse process specific. If my process is claim processing, and I have all the claim people, all the claim warranty organization people are working, they don't care about what others or company is doing. They are more care about the claims that are happening and then how they can reduce the claims so that the company is beneficial. Okay, so how can they improve the quality of the product so that they can minimize the claims? If there are too many claims in one specific, let us say I'm a car manufacturer and there are too many claims on the ignition. So that means there is a problem with the ignition units. I need to fix that. So I need to fix the quality area there so that I can minimize the quality. So those are the things that we are going to bring in. So we will bring in the data that belongs to one business process in one area. So we're going to touch that in more detail as we go. Hope I answered your question, Ananya, there. If not, rephrase it so we can take that question. Avinash, is it recommended the data warehouse should pull data from one database only? There is no rule that we say that we have to go to one database. No, we can have multiple databases. Again, I would like to give a very good example here. These days, I think in the last lecture, I think I talked to you, somebody was asking BI, business intelligence tools. And they were even talking about, some of the vendors, they say, you don't even need to build a data warehouse. My BI tool can do everything for you. I can build you the star schema. Why do you want to build a star schema separately and a different infrastructure, different data warehouse and all that? So they're true, they're right. If you look at it, the way the BI tools have expanded or BI tools have evolved, in the beginning, 10 years ago, a BI tool could connect to one database. That's it. If it is connected to Oracle, it can only connect to Oracle. It cannot connect to another database. You need to install another instance of that BI tool so that you can connect to the different database. But nowadays, one BI tool can connect to multiple databases, and they can pull the data from different systems, and they can merge and build the star schema that the way you like to build it. So if a BI tool can do it, when we design our own data warehouse, we can do it too. Okay, hope I answered your question there, Avinash. So there is no rule that you can only pull the data from one database. But as long as related information is found in different other databases, and that all belongs to your organization, that all belongs to your analysis needs, then bring everything into one place. That is the design aspect here. Okay, if there are different things in different applications, different databases, and you don't have to bring everything just because you're building a data warehouse and building a big database. No, not that. Okay, so hope it's clear there for you. How normalize? Okay. How to normalize the unit of measure? Region-wise, it is dynamically done when the report is run. Yeah, like I said, in the previous example here, we decide what I'm going to store in the data warehouse, and then when somebody runs a report, and most of these BI tools, they know which region the business user is coming from based on the user credentials. So if the user is running a report, if he or she will set the settings, local settings, it will tell clearly coming from which region, whatever it is. Based on that, so automatically data is transformed and shown to the user because BI data warehouse has those conversion information. So it uses that and then present that at the runtime. Okay. If there are 3 types of business in an organization, are we going to have separate data warehouse for each type of business? Yes, Mr. Thiru, that is 100% right, because I don't want to combine the claim business process with the marketing business process with the finance business process, because these 3 are different business units. And if you remember, some of the organizations, people don't even talk to each other. People don't even know from a finance organization, they don't even know who is working in the warranty organization. And especially for us, if we are working in an IT organization, you might be working with different organizations, different group of people in different business units. But each business unit, sometimes they don't even have a choice. So they don't have a chance to meet other business units unless they meet. The organizations have a cultural activities where they come in one place and talk to each other. But very rarely they talk. They need to talk because their process is completely different. So I would build 3 different business data warehouses based on the business process there. Okay. I am very new to data warehouse without using patterns and algorithms. What technology or interface we use to represent data? Uh, okay, so we are going to talk on that, Rajeshwari, because we don't, because it's a data is data, because like I said, we are not um, changing anything. If it's a part database, we're going to bring all the parts. If it is a customers, we bring all the customers. When I say customer, I have customer name, customer address, customer region, everything will be there. It will be in the data warehouse. If it's sales, I will bring the sales transaction into the data warehouse. We are not recreating any new data. We might create very small percentage of new data in order to support the reporting, but majority of the data is coming from operational. So we are not using any algorithms or anything like that. We just bring in and then we use it. So we'll make it clear for you, Rajeshwari. So keep that question for you for a while. So we'll come back to you. From operational database, we are first deciding the dimensions to capture for analysis. Yes, we are going to touch that also in detail. The dimensions are very important. We're going to touch on that. ETL designing is part of our curriculum, so we're going to touch that. After deciding the dimensions, are we going to use one or more database for data warehouse purpose? Yes, we're going to decide what database technology we're going to use. We are going to use Oracle, Sybase, SQL Server, MySQL, whatever it is. So it's again a choice that you're going to make. How are we going to handle the conflicting keys? We're going to talk on that in detail. Swapna will come back to you. Have we already discussed other aspects of only data warehouse is needed, like history, storage, OLAP, or OLTP? Yes, Ashutosh, we talked about OLAP and OLTP. Probably you can take a look at the video from last lecture, so you will be able to follow through those points. The data warehouse, another extended database where summarized data are stored in a unified way. Yes, Michael, you're right. Within the data warehouse, we're going to store the data, and then we summarize the data in the same data warehouse. Again, the reason why we summarize the data in order to improve the performance, because we know that there are some users that would like to see the higher level of data. So instead of them doing the summarization on the fly, we try to do upfront in the backend, in the batch window. When we are building the data warehouse, we build the summaries and make it available so that when they run the report on a summary table, it runs really fast. Okay, we're going to touch those points anyway. Okay. The request is coming from a particular region. Okay, so we're going to touch those things, Rajeshwari. Okay, so we'll give more importance to that as we go. Whoever is having problem, okay, that's good. But I think we covered most of the questions. Will be given any idea related to SAP for data warehousing? Yes, we're going to touch SAP a little bit. There's no question about it because we have data coming from SAP, and we have SAP BW or business objects that are we have used, and I can take some examples and show it to you as we go. Okay, so what it is here, what I'm trying to say here in this, I think some of you are asking this in this picture, what is this conflicting keys are coming? Again, when I say it's a conflicting keys, I would like to elaborate very clearly here. Each operational system might be using different keys. Okay, so let us say, again, this is we're storing this, it's the same information. Let us say it is user ID or something like that, let us say. So in this application, user ID is a character of 10. In this application, user ID is only numeric. In this user ID is again, it looks like a mainframe. It's only numeric. And in this application, user ID is 12 bytes. Okay. So what I have to do here is, in order for me to put this keys into one application in one data warehouse, I should transform it, because again, when I have the key, okay, so even though it is represented characters, it is if a character means it could be a character, or it could be stored number 1, 2, 3, 4 in a quote. So that is also a character for me. It's a numeric value, but it is represented as a character. So that might be the case in this example here. And again, here in this case, user IDs could be numeric, because it's all belonging to one organization, and different applications might be using this. So what I'm going to do is, all of these things I'm going to put whatever is the maximum, and I'm going to put it there so that everything can be accommodated here. So again, this is a character of 12 in my view, alphanumeric. I can store alphabets, numeric, whatever it is. So if it is a numeric alphabets here, it will go easily. It's a numeric, it will go into this. If it is numeric, it will go into this. It's alphabetic, it will go into this. So it is the decision that I'm going to make. Again, this is the right choice. It depends on the application. It depends on the need that you are going to use. So we have to go to that point. But I hope it is clear now for you. So it is a decision that we're going to make how we're going to transform the keys, because you'll have different keys like that. Okay. Metadata, we're going to touch on that. Okay, so say set of databases, analytical tools, we're going to explain those things as we go. Vault data in the data warehouse if it is not necessary. Rohit, that is a good point. Are we going to clear the older data if it is not necessary? I think that is one of the points I said. You have to make sure we have archiving process in place. Otherwise, data warehouse keep going, and that is it's not the right way. Okay, big data versus data warehouse. Okay, I think we have most of these questions answered already. Okay, that's good. Okay, so I think that question I also answered. Okay, perfect. I think we can move on here. I think it's a good point. And the next point here is non-volatile data collections. Okay, so before I go, let me see where we are on the recording. I think we can go another 5 minutes. Okay, good. Okay, so in case of non-volatile data collections, so when I say non-volatile, the data in the data warehouse we don't change. Okay, so in other words, the data comes in, it will be there. We don't delete, we don't update on the fly. So when I say delete, we are going to delete the data for the archiving needs. But in case of operational, we change, we insert, we delete. All those operations are happening. That's why it's called volatile. That means it keeps changing. So that's why I'm coming, because so this we covered this slide. We're moving to the next slide here. So we are in the non-volatile data collection. So so in this example, as you can see here, non-volatile data collections are situations where it is very clearly saying that so data warehouse is a non-volatile. That means the data is going to be more persistent. We don't delete the data. As you can see here very clearly, data comes into the data warehouse and mostly we extract the data. So we are not going to change, we are not going to delete anything. So that's why people are more comfortable coming to the data warehouse. And when they come into the data warehouse and they run the report today and run the report 10 years later, they will see the same data. So that is also a very important characteristic of a data warehouse. We would like to give the results consistently at any given point of time. So if a user runs a report today and he comes back 10 days later, so same report with the same characteristics, same parameters, he will get the same data because we're not changing anything. Okay, so unless a new data came through from operational system, that data will be added and the user will know exactly, okay, what happened. Okay, this was my previous data, now because of new data came, this is a new result. But anything that was there before, we're not going to change. But in case of operational, data could change because you could have an order, somebody could go and change the order. Today you'll have this much order total. Tomorrow, because somebody canceled an order line or whatever it is, the orders will be refreshed and then you have a different total for that order. So, for data warehouse, that is a key aspect. We're not changing on the fly, so it's very important. A lot of people like also because of that, because they come to the data warehouse, run the report, they go to the management. If a manager runs the report, he will also get the same results, so he will have more confidence presenting his results from the data warehouse. Okay. The next point is time variant data collections. Again, this is very important for me because as you can see here, data is going to be stored a lot of years. As you can see here, we have 1 or 2 years of data in our operational system. And again, these days, as we see the data storage space is cheaper and cheaper, I have seen some of the operational systems having 5 years also, 5 years of data. It's also very common these days. But if you go back 10, 15 years, they're very limiting amount of data you can have in operational. Then coming to data warehouse, typically it's a 5 to 15 year data range you'll have in the data warehouse. Again, the time horizon that you decide based on different parameters like, what is the audit requirements for your regional area. For example, if I take North America, we normally try to keep 7 years worth of data because most of the audit needs are like 7 years. But if I go to Europe, there are some countries the country restrictions say that I need to keep at least 15 years for audit purpose, and for sure for India that could be different. So each user ID, each region might have different requirements based on the data limitations. So you're going to keep the data for that purpose. So we're going to keep the data like this, and then we're also another important aspect of time variant is so you should have an opportunity for you to run the analysis. In other words, you would like to capture the time variance. For example, let us say a person working in North India, and he worked there for 10 years. And if he moved, let us say he's a marketing person, he moved to southern India, and after 10 years, and now he's starting another kind of in this region, he's doing the marketing business. So if you lose the data that he has done in North America, then all the work that he has done 10 years is completely gone. So we want to capture that information, the time variance, like so what I did when I was in North India when I was a marketing manager, what all sales I did. I still keep it there, and then when I come to the southern India, my information will be changed. From that point forward, all the sales that I do will be linked to that southern India region. So anytime I can compare as a marketing manager that I worked in India, I can see in the last 2 years what sales I did. It gives combined northern region sales and also southern region sales. But I can also look at it. So what I did last year when I was in northern region, because it is also information is there for my user. And when I come down, I can also look at what sales I did in the southern region. So that is the time variance I'm talking. Not only amount of data that we're going to keep here, we also design the data warehouse in such a way that we are going to make this information available. We're not going to overwrite if a person changes. Okay, like operational system. Operational system, if a person moves from a northern region, southern region, his information is completely wiped out in northern region, and everything is now I'm up to date, current for southern region. Okay, because I'm working there, I'm living there. That's all you will find in the operational system. Coming to data warehouse, you can still do the analysis. So that is the time variance that I'm talking here. So operational data store, we're going to touch here. Okay, before I go there, let me take a break of the video. It's already 30 minutes. Okay, so operational data store, again, this is a terminology that we're going to use in the data warehouse. As you can see here, subject oriented. Again, I don't mix one operational data store with a different bunch of data information. It is integrated, but quick information is it's a volatile. That means we are going to change. As we are building the data warehouse, this is kind of intermediate table. Okay, so ODS is kind of intermediate table, so it is like a volatile. That means it's going to update, it's going to delete some data. So that is the slight difference there. And it is a current, it's most current. It will have a lot of historical data there, but again, operational data store is like intermediate table, intermediate storage area before it goes to the final stages in the data warehouse. Okay. So that is basically what it is in operation. And some of the textbooks, some of the tools they call is ODS or DSO. Okay, both are same for me. Data storage organization or operational data store, pretty much same. So they're kind of a flat file or a flat table in my view, and it is like a regular table in an operational system. Okay. And then very important aspect that I would like to cover here is data marts and data warehouses. It's a very important aspect. I would like to highlight here a data warehouse could have one data mart or multiple data mart. So even if I have one data mart, I would consider that as a data warehouse, or it could have multiple data marts that it's also a data warehouse. So here in this case, I could have a North American data warehouse, Latin American data warehouse, or Asian data warehouse. Or I could have a North American data mart, Latin American data mart, and Asian data mart in one big data warehouse. Okay, so hope that explains now, because a data warehouse is kind of an organizational view. It's kind of a very high level view, and a data mart is a specific business process centric. Okay, so I think that clearly explains. You can go through this definition. It's very clear on that. Okay, And then we talked on this point very well. The goals of data warehouse, as we answer some of the questions, we have a lot of data, and sometimes we can't access it, so we will put it into data warehouse so that it is made available to the users. We need to slice and dice the data whatever way we like, and that means slice and dice. We're going to explain that very well. We would like to move the data different views and see the data in different dimensional analysis. We're going to touch that very well. So whenever we need that kind of requirement, we go to the data warehouse. We have to make it easy for the business people to get the data directly. I don't want business to go to IT every time they need to run a report. So they have the tools there in hand. They have the data in their hands. They can write their own report at any time they would like to do. Just show me what is important. That's also very important for me. So for example, if I have a VP in the organization and we would like to create a dashboard for them and create a dashboard, whatever important data that he or she would like to see, and it is available for them, they click, it is there. Or we can direct that flash the dashboard to their mobile devices or their desktops, their emails, whatever it is, we can do that. So just show me what is important. Those are the questions if you have. The data warehouse is choice. It drives me crazy to have two people present the same data in the business meeting with the different numbers. That is important, like I said a few minutes ago. Data warehouse, you have a persistent data and non-volatile data, and it's not going to be changed. So we're not going to tinker the data. We're not going to change the data values in the data warehouse. We just present whatever is there in the operational in the data warehouse. So we don't use any algorithms. We don't use any regression things. We're not going to change anything. We're going to present whatever is there in the operational in the data warehouse, so that when somebody runs the report, if I run the report and my manager runs the report, we both get the same results at any point of time, as long as the parameters are same. Okay, we want people to use the information to support more fact-based decision making. So this is a very important aspect. Again, I would like to highlight. I would like to make the decisions. I would like to create strategic decisions based on the facts. I would like to make tactical decisions. When I say tactical decisions, immediate needs. For example, operational manager. So there is something happening. Okay, the production is down. What needs to be done? Okay, so we have to go back and look at how many products we have generated, how many products we have yesterday. So do we need more? So we need to tweak a little bit in the production line, whatever it is. So those are the tactical decisions that are needed, immediate decision making. Strategic decisions are like a company-wide decisions. Okay, so we are as an organization, we are making these changes so that it is going to resolve this. So we have these 3 promotions now. We're going to add a new promotion. What are we going to gain with that? So those are the strategic decisions. Okay. So again, we have some more points here. The data warehouse must make an organization information easily accessible. Must present organization information consistently. That's a very important point for me. Consistency is a very important. I'm stressing consistency because in order to have a consistent data, you need to have a proper design on the ETL. You need to proper validation during the ETL process. You need to make sure data is properly transformed without any issues. So there is a lot of checks and balances that you will do before you deliver the reports to the users. So the consistency very important. The data warehouse must be adaptive and resilient to the change. So this is another important point that I'm telling you. If you go and buy a BI tool out of the market, I'm sure it is going to meet the need for you to build a data warehouse star schema right there and meet the business needs of analysis and reporting. But is it adapt? Can you make the changes of the business? Let us say a business process is changed. Can we bring that easily into this BI tool without any help of the BI tools, the vendor knowledge? So that is the challenge that you have. If you have a data warehouse built yourself, you know the design, and then you can easily, if there is a business process change in the back end, you can bring that business process change into your data warehouse easily the way that is changed. Okay, data warehouse must be secure. There's no question. We don't want to have unsecure information. Must serve the foundation of improved decision making. Yes. Data warehouse is there for strategic decision making, tactical decision making.
The first connection.
I'm sorry. I could hear noise. I don't know everybody else can hear the noise. I don't know, Raghava. Somehow, all of a sudden, something was unmuted. I don't know what happened there. I didn't do anything, and everybody is muted here. Okay, it's a glitch. It never happened to me before. Divya, let me check. I don't even see Divya here. Divya, I don't even see that name here anymore. I don't see anything unmuted here. Interesting. Okay, perfect. I don't know how that happened. I have not unmuted, so probably she logged off. Okay, good, thanks. I don't know how she could unmute herself. Anyway, that's interesting. Okay, perfect. So back to reality. Technology can do any magic here. Probably. Okay, we'll stop right there. So business community must accept the data warehouse. It's deemed successful. This is another important point because I'm telling you very well because we have too much data in the data warehouse. And if you have unsatisfied user, I'm telling you, they will spread the word. Within no time, you won't have any users using the data warehouse. If you have the data inconsistently presented, immediately people will go away from your data warehouse. So all these points that we have covered in these last two slides are very important, and consistency is very important. We want to make sure data is consistent, accurate. All those aspects is going to help build the credibility of the data warehouse in your organization. So it is very important, the goals of this data warehouse. So here in this architecture diagram, again, we're going to, it's very, like I said, this is introductory lectures. So I'm going to show this. I'm not going to go each one of them clearly here. We're going to elaborate as we go. So as you can see here in the data warehouse, very high level, so you have a source systems, you have a processing area, we call it staging area. Again, every data that comes from different systems will come to the staging area before it goes to the actual data warehouse tables. And then it goes to the data warehouse tables, dimensions and everything, and then it goes to the presentation area, where the presentation area users will be connecting, and then end users, as you can see here, they connect to the presentation area. They never directly connect to the database data warehouse area because it is too clumsy for them. So we will give the access to the presentation area for the end users. There could be some users, again, exceptional basis, so power users. I might give some access to the ODS. Again, very exceptional. You know, they know the business, they know the data very well. They've been in the industry for a long time. So I'm comfortable. I'm confident that they're not going to cause any issues. I might give access to some of these areas here, but for sure they don't have any business in the staging area because staging area is nothing to do for them because it is all a big, an entry point for the data warehouse. For IT people, yes, they will have access to all of these areas, but for business people, mostly the presentation area, and some business users might go to the ODS and fact tables and things like that, but they never come to other areas in the data warehouse. Okay, staging is part of data warehouse, yes. Requirements, again, security requirements is very important. We're going to touch on this very in depth. But again, security requirements in my view here is you need to take into consideration what kind of security you would like to have in the data warehouse. So again, I have pointers here, grant, revoke, and different database type of security aspects. But for me, if a data warehouse is, you're building a data warehouse for a specific business process. So you don't need to restrict the data for all the users in that business process. So as long as that data warehouse is given access to all the users in that business unit, you're fine. Nobody else can get to the data warehouse. So as long as at the database level you have controls, so you don't have to worry about it because within the business unit, everybody would like to have the data. So let us say I have a bigger data warehouse like what we have here. All the regions, so all the regional data is here, like North America, and Asia, and Latin America, and you have a global data warehouse, and then you have all the users in this data warehouse which has access to all these regional data. If you say you don't want to give access to all the regional data, you can give only North American users come to this data warehouse. You can restrict that. Okay, that is another way to look at the data warehouse security. Okay, that is another point that we can have. Data integration, again, my point of view here in the data integration is specific data warehouses. We would like to have a 360 degree view of the business, because we would like to complete the picture of the data warehouse, the business unit, put it in the data warehouse so that the data is there for all the information related to that business unit, so that they can do any kind of analysis. Okay, so we're going to talk about conforming dimensions, conforming facts. We're going to touch these topics in detail as we go into the class. But again, for me, in the data integration here, the slide that I'm trying to here is, we want to make sure data we're bringing here is, we want to make sure it is belonging to that particular business unit, and then we are going to make sure the data is properly transformed and then put it correctly into that particular ODS or information, whatever we're going to keep in the data warehouse. So another requirement of data warehouse, data latency. What is the latency that we would, how quickly we can deliver the data to the end user. Again, like I said in the last lecture, typically the data is 1 day old, because you can't have the data, today's data in today's data warehouse. Again, that is what most of the business users will ask for it. I would like to see real-time data in the data warehouse. I don't want to wait till tomorrow, but you need to balance that. We're going to touch that point very well. Archiving is a very important aspect. So we have to put the archiving rules and calculations. What are the rules and regulations when we're going to archive the data? It's again in the agreement with the business, because we can't make your own decisions. We need to make sure organization needs, if the organization needs the data for 10 years for audit purpose, we need to keep for 10 years. Okay, end users, again, so they are morely running the reports, doing OLAP, analytics, data handoff. Again, those are some of the terminology that you will hear in the data warehouse. Okay, so the next one is technical requirements. Okay, we're going to touch on these things as we go. Again, very well, ETL tools versus hand coding. You can build your own ETL tool. Like I said, it's not rocket science. You can build your own ETL tool based on the needs, or you can buy a new tool out of the market if the organization has the money. So we also need to work on batch updates, data coming batch into the data warehouse, or you update the data streaming, like, as the data happens in the operational system, bring directly into the data warehouse. Horizontal versus vertical task dependencies. Okay, again, this is business specific data, how you want to bring in, automate the schedule so that data is automatically pulled into the data warehouse. Quality and data cleansing is again topics that we're going to cover. Metadata we're going to cover, security, staging area. All of these are the different aspects of architecture that we're going to deal when we cover the more technical aspects of the data warehouse as we go into this course. Data warehouse design, again, some of the slides here I have elaborated, like, so we started with the ER diagram that represents the corporate data model. Start with the ER diagram that represents the corporate data model. Again, ER diagram is for operational system design, so entity relationship diagrams. So this is what we have in the operational data warehouse, operational data systems. So we start from that and then slowly transform that to a star schema. Okay, that's what we're talking here. So turn relationships of the ER model into artifacts in the data warehouse. Again, when I say relationships, whatever relationship we have in the ER diagram, we're going to transform that into actual business type of metrics. Business can easily understand type of data in the data warehouse. That's basically what it is. Remove the data that is used purely in the operational environment. You might not bring some of the data. You can just eliminate some of the data. Enhance the key structures. We will do all these things as we go. Add some derived data. You can do some calculated data. Let us say you have the sale and then you have taxes. So now you can come up with a calculated value like total sale. So total sale will be a sale plus taxes, delivery charges, whatever it is. That will be total sale. Okay, so you could calculate that and store in the data warehouse. Whereas an operational system, you don't store those totals. You calculate them on the fly when somebody is writing a report, because you have the sale, taxes, and everything. Come to the data warehouse, you might do some pre-calculation, or sometimes you also do the summarization. Okay, so we are going to learn all these things because again, these first few slides here, I want to give you overview of what we're going to end up learning in this course. That's why I'm going a little bit faster, but we're going to deep dive in each of these topics as we go. Okay. Again, this is another example slide you can see here. In case of operational, you might see something like this. You have links coming from a program coming here, updating here, updating here, updating here. Going, you can see here a chain of data going through. If you want to get some data from here, you cannot directly get the data from here. You have to get first here, then go here, go here, go here. Or you join these two tables and join to this table, join to this table, then you can get the data. Whereas in data warehouse, you're kind of grouping data together so that it's easy for me. So all the data related information is in one table. It's a little bit larger table, but all the data is in one place. I don't have to join the tables. All the information in one place. With one access, I can get the data in one go. So that is why it is much faster. So these are some of the design techniques we're going to learn as we go. So this is a very simplistic, very high-level view that I can see. So in case of operational, you have zigzag connections moving from different relationships from one table to other table. Whereas in case of data warehouse, you kind of group the tables together, bring all the information in one place. That's why these tables in the data warehouse are going to be very large in nature. So here you might have 10 columns here. Here you can see here 10 plus 10 plus 10 plus 10. You might have 50 columns table in the data warehouse, very common. Even sometimes I've seen 150 column tables in the data warehouse. So it's very common. And then some of the tables are very deep. That means millions of records in the data warehouse tables. Whereas here, table sizes are very reasonable size. They don't go too big. Okay. Again, you can see here design technique introducing redundant data. So the reason why, in case of as you can see here, if there is an update coming, if I have a duplicate data. So that means I have to update in all of these tables. Okay, so that's why what we do in operational is we put the description in one place. You can see a description is in this table. So when there is an update coming, so it will only update in one place. And whenever these people are accessing the description, they go to this table, joining to this table, and get the descriptions. And if they are using this table and they want to find the description, they use this table, join into this, get the descriptions here. But when there's an update, they only update in one place. Instead of updating 5 different tables, they're not updating the descriptions here. Whereas in case of data warehouse, you can see update comes, description is here in every table. So we're updating every place, but when it comes to access, you're getting the data in one table, you're done. So you don't have to join. So you see the goal here. In case of operational system, I am trying to minimize the update process faster. Whereas in case of data warehouse, I would like to get data as fast as possible. I don't want to waste too much time going and chasing through the database to find what data I need. As long as data is in one place, I can go and fetch and go away much faster, much easier, much faster. Okay, so that's why I said in the in the beginning, databases in the data operational systems are normalized, and in case of data warehouse, we're going to denormalize. We're going to expand that in the next lecture for the performance benefits. Okay, we're going to cover that aspect. Again, there's another interesting concept here. You can see here. We're going to take a look at this. If we have information like this, these two tables are different tables. Now you combine everything into one place. Okay, so that you don't have to go to 2 different tables, joining by account number to get this. Everything is in one place. So that is also another design technique. So that is much faster. Separation of data. Okay, so that's another point. The other aspect here is you can see here we're doing the derived calculations. So like I said, you might have the information here, but now based on the taxes, FICA and other, you're going to calculate annual pay and store that annual pay physically in the data warehouse. That means at any given time, if I want to find an annual pay, so it is right there. You just go to that particular attribute, fetch it, present to the user. You don't have to calculate on the fly. Okay. So what does that mean? You're still doing the calculation, but you're doing the calculation of not online, not the dynamically generating the calculations. You're calculating them offline, doing the batch window, and then physically storing the database. So somebody might be questioning me, why are you storing all this data? So for me, the goal is how fast I can give the data to the user. and I don't calculate each and every field. I only calculate the fields that are most frequently used. Okay, there is a limitation. I can't go and calculate every one of them. Let us say I am the user coming in. I only come once a year, and I calculate this annual pay. Just for one user, I don't create that field and store the annual pay in the data warehouse. If I have 1,000 users trying to calculate them every day, they want to see what is their quarterly sales, then I better store the quarterly sales in the data warehouse, so that for all these 1,000 users, they don't have to calculate on the fly every time they run the report. So they can just go and fetch it. Okay. So that is another thing, and creating indexes. It's a very important aspect. We're going to cover a lot in this in the coming lectures. We're not going to go deep dive here, but indexing is an integral part of data warehousing. We're going to touch that very well as we go into the next lectures. Okay, again, this is a very important aspect before we discuss. I know we already passed 5 minutes. I'm going to stop in the next 1 minute here. This is a very important aspect I would like to cover. Forget referential integrity. What I say here is we are introducing some redundant data. Okay, in case of operational system, we will have referential integrity, very tight referential integrity. So here in case of data warehouse, so we are going to have introduced duplicate data. So we will still have a primary key, foreign key relationships and all that, but don't be rigid on that. Say I would like to make sure I have primary foreign key relationships, make sure all the data here, I don't have to have duplicate data and all that. So we are going to introduce some data duplication in the data warehouse as long as it is going to help me in the performance of query execution. Okay, that is important aspect. We are going to maintain the relationships, but just because we have to maintain the relationships like we do in operational, we want to make uniqueness and all that. We're going to flexible. We're going to be a little bit flexible here. We're going to add some redundant data, and then we're going to go from there. Okay, so we're going to replicate representation in a data warehouse environment in a patently concurrent approach. Again, we're going to follow for sure database approach, like database primary key, foreign key relationships and all that. We're not going to completely go away from that because we are going to build on the database, but we're going to be a little bit flexible. Let me put it that way. Okay, that's my point there. So we're going to add some concepts on dimensional modeling. Again, these are the slides you can breeze through because we're going to spend considerable amount of time on this fact table, dimension tables we're going to cover. Then fact tables are measurements. We're going to keep only the measurement data in the fact tables. We're not going to mix dimensional data into this. Again, these are all the design aspects we're going to cover in depth as we go into the course. Okay, so let's just pay attention to this. We are introducing the terminology, but we're going to go deep dive. So let's not spend too much time here. As a fact table, like I said, it will have only the measurement data, and if I come to the dimensional tables, that will have all the dimensional data, like customer dimension will have customer information, time dimension will have time data, and if I have product dimension will have product details. So all that details, like descriptive details, will be there. Okay, so as you can see, who, what, where, and when information will be stored in the dimensional table. Okay, so we're going to go deep dive on this. So don't think that this is what we're going to cover. We're going to go in detail. So in case of OLTP design, as you can see here, I also showed here you have primary foreign key relationships, and this is what we are going to use in case of if you want to select some data, joining these tables, location, state, and countries. But in case of data warehouse, everything in one table, and you're going to have one table here. See the difference here. So the front table is one table, whereas in case of operational, you have location, state, and country in order to pull all the information. Whereas in case of data warehouse, all the information is kept in one table, and now you're just going to one table to fetch it, which will be much faster. So again, the reason why it is, when you say this table could be in a different different disk pack, this could be in a different disk pack, this could be in a different disk pack. When I join, I need to bring all those information into memory, and then pull the data that I needed. Whereas here, you have every information is combined in one table, and we can easily fetch it in the data warehouse. Okay, again, time dimension, like I said, time dimension is elaborate dimension in the data warehouse. It could have all possibilities: quarterly, half yearly, yearly, fiscal year, days, weeks, everything, week of the day, month of the day, like January, February, March, you can see quarterly analysis. All these analysis you can do in the time dimension, which is a very sophisticated dimension in the data warehouse. Okay. Product dimension. Again, these are some of the examples I'm giving, so just go through this. There's not specific thing. Again, I would like to stop right here. Okay, so we have a sales fact table, and we have these dimensional tables that we have here. So as you can see here, these are the different dimensional tables that are connected to the fact table. So again, my point here is trying to show you at the end of the day, we are going to arrive to this. So probably on the 7th, 8th lecture that we will be arriving this, but I would like to show you this is how simple I would like to see my data warehouse. As a business user, I come in, I would like to see a fact table, time dimension, location, dimension 2, dimension 3 product. By looking at this, I will be knowing, okay, this is the fact table I have. I can do the analysis by time. I can do the analysis by location. I can do the analysis by product. I can do the analysis by product promotion if it is. I can do the analysis by customer if it is a customer dimension. So basically what I'm trying to do here is by looking at this, I don't need any other details. I can clearly see, okay, as I see the star schema, as a business user, I know that I can do the analysis on all these dimensions for these particular fact values. Okay, that's all I want you to understand now, and then as we go into the next lectures, we will get to know more details. Okay, Snowflake schema, I just put it here, but don't worry about it here because again, it's like we are going a little bit farther into the lecture. But I think we have a couple of more slides. I think it's just we are going to cover these topics anyway in detail in the next couple coming lectures. Okay, so let me stop the video here, and then I will take up some questions. Those of you who would like to drop off, go ahead. I think that covers the lecture. Okay, so again, some of you who are there still online, I went through these slides a little faster because these are just very simple. You can go through that. There's not much explanation that I need to give because we are going to deep dive on these topics as we go. Or at least I want to introduce this terminology, as we go into this this lecture, at least very high level I would like to give. So as we go into the next lectures, we're going to go more deep dive into the data warehouse concepts. Okay, let me take these questions before we disperse today. I think I have some questions here. Okay, so now I'm here. So as we are storing the reports in the data warehouse for no volatility, the size will increase. Yes, I agree 100% Swapnil. The size of the data warehouse will grow significantly. So that's why I'm telling you we need to have our archiving process in place. Otherwise, your data warehouse will grow within no time. So that's what we need to be very careful. We are not updating the data warehouse. We might be looking at the stale data. So when I say not updating, we are going to bring in the new data as the transactions happen from the source systems. But like I said, in the ODS level, we are going to have some updates happening there. But when it comes to the star schema, as you have seen, like a fact table and dimensions tables there, so we're not going to change any of the data there. So that's why I said it is, it's not going to be stale. It's going to be what it is. Whatever sales you have is what you have. So and also, like I said, if a marketing manager moved from one region to other region, you would like to keep that information, even though it is very old. You would like to keep that information, thinking somebody else would like to do the analysis. Okay, so that's the reason why we keep it. Okay, Suresh is telling some of the old lectures are there in somewhere in the Google Drive, so probably you can post on the Taxila, Suresh, so that other people might be able to see that. Okay, so Rajat is saying, suppose that I'm going to store the state of on-off, suppose a 10-day state on, and I am updating the data in the data warehouse hourly basis. I'm sorry, we're not going to update the data warehouse hourly basis. Okay, again, we'll touch on that. Okay, so if you're doing that, that means it's going to be very challenging for you. Okay. but that should not be so not advantageous. What possible solution for the kind of scenario? One that I thought it triggers anything better available. We were going to cover the topic, Rajat, because for sure what's going to happen is we would like to take a state. You could have a trigger from an operational system as and when it happens, comes to the staging area, and it could stay there. And then once all the data comes in, you can consolidate and push it to the data warehouse. That is a possibility. But most of the times, what I would like to do is when we decide, for the transactional data, transactional data will come as the data happens. But in case of dimensional data, for example, customer, there is a customer change happens. Those changes we are going to take into data warehouse. But when we are changing that particular data, again, when I say volatility, there could be some changes to the dimensional data, not for the transactional data. Okay, we're not going to change transactional data. So when there is change in the dimensional data, and if we don't care about historical purposes, and if if a marketing manager worked in northern India for 10 years, he moved to southern India, and if we don't care about the analysis, we could override, the current region to southern region, and then all the work that he has done in northern region is gone. So that is a possibility, but again, it all depends on what kind of analysis you're doing. When does the SCD come in? We're going to touch that SCD, slowly changing dimensions, for sure. That is the point that previous question user was asking. How are we going to change? Yes, slowly changing dimensions are going to help us to manage this dimensionality. So we're going to cover that in the next lectures. Which tools do we use for archiving in data warehouse? It's pretty much standard data warehouse database tools, whatever database tools you have. We're talking about data in the database. So whatever tools you have for database, you're going to use for archiving. Sometimes you just use manual, select and delete and push it away. So that's also possible. In the research field, we have to keep data for many years, like 10, 30, 40 years for analysis to drive some results. Entire research do we use data warehouse there also? Yeah, probably, but I have not come across myself. There could be some data warehouses that you will keep a long time if you're doing some research type of data, but most of the times the data warehouses that we deal with are operational data, and any operational data that you're going to use, if you go beyond 5 years, there's going to be too many variables, and you cannot really do the analysis beyond that. And if there is a specific data that you would like to use for research purposes, yeah, you might keep it for a long time, but not entire data warehouse. Okay, so you also need to have a balance on that. What is the tactical? Okay, we talked about that. ODS and data mart. ODS again is like intermediate table. I think, like I said before, a data mart is pretty much like a business process oriented, like a star schema. And that data mart now, I think, with the star schema introduction, I can say star schema is a data mart. Okay. How frequent data collection summarized daily, weekly? Yes, we have seen data warehouses. Most of the data warehouses that I have in my organizations, I was managing 5 data warehouses in the last 10 years. So most of them, like 99%, we had one data warehouse where we had 2 time updates daily, but everything else, all other data warehouses, we only do updates daily. And we have some data warehouse, 2 data warehouses where some of the processes we only do the updates weekly. Okay, so you decide, which ones to run daily, which one runs to weekly, which one runs monthly, but it's again a design decision based on the business needs. But mostly daily is most frequently used. How to ensure the data is reliable? Make sure you have good testing and make sure everything thoroughly tested before you release to the users. That's all I can tell. Okay. Problem there. How to access the report data from a data warehouse with the help of different tools like Cognos, etc. Yes, Swapnil, yes, we have. You can use typical SQL commands and you can access the data, but that's why I was telling you need to have some reporting tools connected to the data warehouse so that it makes more meaningful for the data that you have designed. So you got to have some tools that connect to the data warehouse and then run the reports. Again, especially multi-dimensional analysis and all that, you got to have a tool that is capable of doing it. And if you want to build it yourself, it's not. It's going to be a complex work for you. It's not easy. I'm telling you. Staging area, it comes in the data warehouse. Yes, it is part of a data warehouse. Can we store the data of a data warehouse and index into PostgreSQL Server for faster search and retrieval? Amitesh, yes, you could store this information. There's no question about it. Whatever best approach you have, the best infrastructure you have, we can store. I don't have any preference there. Okay. Do we have a data warehouse? Can we create data warehouse at cloud level? Is it possible keeping in mind a lot of data? Yeah, I think slowly people are moving to the cloud. I have not built myself one in the cloud, so I don't have any experience, but I have seen people are building data warehouse on the cloud so that it is available for wide area people. It is much easier. Data integration, yes, it's part of the transformation ETL, correct? How do we manage the situation? An order is placed yesterday and now it is in data warehouse, but the end client decides to change the order. Yes, that is the situation. Like for example, if the order is coming yesterday and then there is a change in the order, those changes, if the business is going to measure the orders, if the business is going to measure the orders, there is going to be variability in that case. There's no question. There's nothing you can avoid. And that is one of the things that you need to be very clear. And that's why whenever you have orders analysis, you will also complement with the shipment analysis so that you can clearly see, okay, when order is finalized, you have a correct shipment so that you can complement to each other. Okay, so so when you have order data warehouse, so you're trying to keep the analysis of orders. Yes, that variability is there. You need to capture that. There's no escape from it. If you want to do the analysis, but in some of the businesses, because of that variability, business might say, I really don't need to see that in the data warehouse because it's going to change anyway. So I will have something today, tomorrow it's going to change. What's the big deal? I can go to the operational system, I can get it. So operational system will have realistic information at any given time. I can go and look at it directly there. So there could be an argument there. What will be the final value in the data warehouse, yesterday order or the modified order? Like I said, in the data warehouse, you have a choice to keep both, but mostly you just overwrite it in the data warehouse also. If you want to keep the historical information, previous order and current information, you can keep both. So that the latest order, that you have in the data warehouse will be the current, final order, okay, updated order. Okay, and you can go to history. So again, Amitesh, it's a design decision. What do you really want? Do you want to keep the order history so you can bring in every time there's a change, you bring in and you have a history maintained in the data warehouse. So that tomorrow you want to go, okay, I had this many orders created with this much, and then at the end it has changed to this. You would like to do that kind of analysis, you can do it in the data warehouse. Whereas in case of operational, data is overwritten. Okay. Yes, Pradeep, yes, data warehouse is more denormalized. The main intention of denormalization, like what we have seen here in this slide, here, and also in this slide, this is also denormalized basically. Here it's all normalized database because you have to avoid redundancy, you split into smaller tables. But here we have brought them together. That means we have done the denormalization. Okay, so we're going to touch that examples in the future lectures, but again, this slide clearly talks about denormalization. Again, why did we do denormalization? To improve the performance, yes. While updating, as you mentioned, it will upload all other tables. It's not time consuming. Okay, Rajeshwari, you're right. We are going to update the data delta increments most of the times. Okay. So delta increment, that means the changes that happened yesterday are only the ones we're going to bring in. We're not going to load everything that is happened for the last 10 years in the operational system. We're only going to bring the delta changes every day and update it. but I will also take the statement back, and I will say there could be some tables that are smaller in nature, like a dimensional tables. I might do a full refresh every day because it's a smaller size table. It makes more sense for me because in the operational system, I have an update, like somebody was talking, I have an update in the morning 8 o'clock, I have an update at 2 o'clock, I had an update 3 o'clock, and I have another update at 5 o'clock in the evening. So let us say the description was changed, like address was changed to ABC, then he realized, oh, that is not right, he changed to XYZ, oh, that is not right, he changed to again back to ABC, and then at 5 o'clock he decided, no changes to the address, go back to the previous. That means he had 5, 6 changes to the same address field during the day. So, do we take all those delta changes and then apply them in the data warehouse? You could do that. Or you make a decision saying that, okay, you will have this kind of variability, this kind of changes, too many changes happening on this table every day. So let's forget about these changes. Let's bring full content of the table, whatever it is, the end state of the table as one time a full refresh, because this table is smaller size. So you can also do that. Okay. Normally having data, so hope it is clear for you, Rajeshwari there. Earlier we spoke about data warehouse normally having data 3/3 normal form. Would there be benefits using lesser normalization, say the second? Again, like I said, we'll bring the third normal form, but again we denormalize it. So that is the design aspect we're going to learn as we go into the lectures. Ramya, today is too fast. Yes, I went through a little bit faster in the slides, but again, as you see here, there's nothing in these slides. They're just, I want to give you some information. So it's pretty self-explanatory, and I was just trying to explain to you what these things are as a very high level, so that we're going to deep dive on these topics anyway. So that's why I went a little bit faster, because we're going to spend a lot of time on this as we go into the semester. Can you help me with any example database that can be used for data warehouse practice? For example, database designing, there is a database, there are different databases that, database engines that are out there. Like I said, I'm not favorable for any specific database engine because I worked on Sybase, I worked on Oracle, I worked on SQL Server, MySQL. All of these are phenomenal. So you pick and choose whatever is best for your organization needs. So I don't want to, name a specific one that it might be good, because it might be good for me, it might not be good for you. And it depends on the size of the data, size of organization, and all that. So you can go through these online. There's a lot of information on that. So you worked, I think you said you worked on a data warehouse project, but we had tables but didn't have redundant data. Again, like I said, probably the design that you have there, I would like to take a step back there again. I'm going to tell you, there are some older organizations. They call a data warehouse means as long as it's a reporting, as long as it's very big. They might not follow any of the design techniques that we learned in this course. So they will still call that as a data warehouse because it is large. It is doing analytics. That means it is doing analysis for the business users, and they call that as a data warehouse. In their view, yes, it is right, and I don't contradict. And I have a data warehouse like that. We don't follow any of these things that we learned in this course, and I still call that as data warehouse because that is how the users are treating that. So there's nothing wrong with that. So probably that is the case for you, Mr. Om there. We are using Oracle Discover. Yeah, that's probably the same thing. As in case of data warehouse, we create a single table, or there are any limitation on the table size. Again, there is no limitation on the table size as such, because the table size can grow as big as possible. And like I said, I have in one of the SAP BW data warehouses, I have one table which is almost 1 terabyte, close to 1 terabyte. I think it was 700 gig or something like that, gigabytes at one time. So I have not seen recently because I'm away from the data warehouse. But yes, it could be depending on the design. We'll see how it goes. Do Data Mart has all the properties of data warehouse, like non-volatility and others. Yes, yeah, data mart. We will follow all other characteristics. Data, like I said, a data warehouse. I call a data warehouse even if it has one data mart or multiple data marts. So, and also like I just explained before to Mr. Om, I will also call a data warehouse even if I don't have even a single data mart, because that is what people are going, because it is a big data database, and it is serving the user needs of reporting and analytics. So they treat that as a data warehouse. That is also one definition. I can't move away from that. Okay, so I think we covered all the questions here. Again, thank you for joining today. We'll stop right here, and we'll see you next week.